Good afternoon. I'm Eric Schultz. I'm product manager for Amazon VPC. I'm excited to talk about VPC migration today. How many folks have VPCs today? By show of hands. And how many of you would like to migrate into VPC? Excellent. We're gonna spend some time with Matthew-Barlocker. He's a chief architect from Lucid Software, and he's going to talk about how he's migrated into VPC. But before we jump into that, I wanted to take a moment just to talk about where we've been and where we're going. VPC was first launched in 2009. It was an extension of a corporate data center. You could create one large VPC with a private IP range that you designate, set up a VPN connection, and burst into the cloud. If you were sitting in the cloud and you wanted to get to S3, you needed to traverse down the VPN connection, out your corporate firewalls, around to S3, and back around again. So we'll talk about how we tackled that. When we first launched it, we had VPC in a single availability zone in a single region. There were no security groups because the only way in and out of a VPC was through your corporate premise, or your premises, so you would come through your firewalls. So we had no security groups, no route tables, no ACLs, VPN connectivity to get in and out. In 2010, we introduced the management console. Has anyone tried to create a VPC by hand using the API? Takes, how many days does that take? It's not the friendliest thing to do. So we added the management console. Now you can create a VPC. It's about 3 seconds and 3 clicks. In 2010, we launched our EU West 1 region. We added auto-scaling and the ability to assign specific private IPs to instances. In 2011, we added the Internet Gateway. This was for my very first day at Amazon. My boss said, hey, Eric, make VPC connect to the Internet. How difficult is that? Just connect the VPC to the Internet. So in 2011, we got there with the Internet Gateway. We had to add security groups into VPC. We added elastic IPs, network ACLs, route tables. We did a global expansion to all regions, multiple availability zones, dedicated instances, elastic load balancing, elastic MapReduce, multiple VPCs per account, multiple VPNs per VPC. We also had elastic network interfaces. That's one of my favorite features. So 2011, big year for VPC. 2012, we added support for Amazon Relational Database Services, Amazon Elasticache. We did multiple IP addresses per interface. And this year, we've added support for Amazon Redshift. We just added support for what I'll call ephemeral public IPs. Has anyone tried that yet? Where you can launch an instance and say, automatically assign this a public IP, so you don't need to go back later and touch the instance and give it an elastic IP. We added DNS host names. And the big project that we've been working on is default VPC. So what we're doing now is we're onboarding all new AWS accounts as VPC-only accounts. And we're doing that in all regions except US East 1, and we're going to turn that on very shortly. So we're onboarding all new customer accounts as VPC-only. And now we want to work on the next phase, which is building tools to enable VPC migration. I put down a quick list. This is just so you have it in the slide deck if you come across it later, all the different features we've launched. So VPC migration, Matthew will talk about how he's done it to date. I'm here this week talking to people to understand how would you like to migrate to VPC? What are your specific use cases? How would you ideally like to do it? Let us know, and then we're going to spend time building the tool sets, methodologies, and processes to help you migrate into VPC. And that can range all over the board, but please let us know, how would you ideally like to do it? What tools would you like to see? Let your salesperson know, or your solution architect know, or drop by our booth. Let us know how you'd like to do a VPC migration, and we'll go ahead and put that into our planning for the upcoming months to go ahead and build those tools. So with that, I will go ahead and introduce Matthew-Barlocker, Chief Architect for Lucid Software.
Yeah, woo. Hey, that's better. That's the warm welcome. So a little bit about me. I am the chief architect for Lucid Software. I'll tell you what we do. But most importantly, and this will come back into play later in the presentation, I love to fly planes. More accurately, I love to fly plane, perhaps. I went on one plane ride where I drove. I had the yoke in hand, and it was quite amazing. I loved it. I need 40 hours to finish my private pilot's license. Of that 40 hours, I've done 30 minutes, so I'm well on my way. It only took that 30 minutes, though, for me to realize I loved it. It was amazing. I want to do it. And that'll come back into, we'll bring that back into the presentation momentarily. About Lucid Software. It's a small startup based in Utah. And we have two products. First is Lucid Chart. Lucid Chart is an online diagramming software. It replaces Visio, and it is highly collaborative. It's as if you took Visio, put it in the cloud like Google Docs. So very useful. Second one, take that same collaboration and apply it to online print and digital publishing. It's called Lucid Press, just released about a month ago. Go and try it out. Feel free. I named these because I want you to understand our use case for going to the cloud, use case for using Amazon, what problems we may run into and did run into during this migration. So we started out EC2, and now we're entirely on VPC, and that's where I'm going with this. Each document has a number of properties, and one more here. They get to be very, very large. Every document in our system, we track all the changes on them. We track everything you do so that at any time you can go to a point-in-time restore and get that. Those changes get to be awfully large. We track, colors, position, just everything about them. Every move you do, we get it. We have real-time collaboration, so if one person goes in and starts editing, another person has to go in and edit. It becomes twice as hard, or we have to use twice as much network traffic, compute power to operate on this same document as we would with one person, and it only gets exponentially more difficult as you add more users because they have conflicting changes. We have to go back to the server and try and figure things out. We use high-quality images. We allow imports from Twitter, Flickr, Facebook, and we save these at the same resolution you took them at, which gets very expensive. Lots of images. And then vector graphics. Vector graphics, I say that, but it doesn't sound difficult, right? Until you realize that every one of our fonts, every word, every letter that you type, we store that in vector format because it's custom fonts. You can upload your own font and have it displayed in the browser and on print, same way. It's very big, very expensive, very hard to do, and we needed to move this to VPC. Some technology that we use at Lucid, I just want to highlight a few of these, and I assume you'll just read the rest. We use sharded databases for all the data. We use service-oriented architecture. We needed something, this is actually one of the first things I worked on. We needed something to release independently, fail independently, scale independently, and so we moved there. And we have a number of monitoring solutions. As I mentioned, we are 100% 100% on Amazon. We are exclusive Amazon users. The services on Amazon that we use, every service that we have, our own services, we use an auto-scale group. We have a load balancer in front, the ELB. Each one of those services is backed by a database, so sometimes we use RDS. Each one of them has Route 53 pointing to it using a CNAME or a record. We use a lot of services. In fact, we're highly tied into Amazon. We're happy. We don't intend to leave anytime soon, so we don't mind getting so intimate with Amazon. So 2012, about a year ago, we wanted something more robust. EC2 was not cutting it for us. There were a couple reasons in particular we wanted to move, and we just needed something more robust, more secure, better for us that would fit our use case a little bit more than EC2 did. We looked around a little bit, and I in particular looked around. I had used Rackspace before. it wasn't going to cut it for us. We needed the auto-scaling ability. We needed some features that Rackspace just didn't have. We looked at the Google App Engine, it just didn't work. As a startup, we didn't have the capital to bring it all on-premise. So VPC, I took a look at VPC. Just like flying a plane for 30 minutes, VPC did not take long before I realized that was the one. I loved it. It was amazing. The time I looked at this, enough of those features that Eric had went over were released that we could use it and be satisfied using it. So we began to do it. Let me name these reasons in particular. Pricing. VPC is free. There's nothing special about VPC that you have to price out. You don't have to pay for it. Subnets are free. Everything about VPC is free. You pay for the usage, the instances that you use, just like you would EC2, but the VPC specific things are free. They're bundled, you get them. That was nice for us. We already were aware of the pricing in EC2, and it would be the same for us. We already depended on a number of Amazon services. They still work. No issues. Everything worked as intended, as it was already implemented. No code changes, no routing through our internal in-house VPN solution, thanks to Eric and his team. The enhanced features, I'm going to go through some of these, but my favorite feature of all is the internal ELBs. Prior to VPC, we actually had internal services. They were firewalled off. To get to them, we had to manage our own load balancers. I hated doing this. It was my job. If one went down, I had to manage it. It was a pain, the Route 53 stuff, getting IP addresses. I didn't like it at all. Internal ELBs have solved this for me entirely. We use them exclusively. We dropped all of our load balancing boxes, and we're using internal load balancers, so I love them. There are more features, but that's my favorite. Security. There are a number of reasons that make security really good in VPC. Your nodes in the private subnet, so you'll have public and private subnets if you've already investigated it. If not, I guess you still will have those. You get internet addressability in the public subnets. You get no internet addressability in the private subnets. You are NATed off. We wanted that. That was a big driver for us. We were sick of the constant spam attacks on all of our servers, so that was very advantageous for us. We decided to go with VPC, obviously. During the migration, we found a number of other things that were just great. We were thrilled with them. We had no idea going in that they would benefit us. We didn't even know that they existed, but we found them. We were very happy with them. Among those were the, not just internal load balancing, this reads differently, but security groups for the internal load balancers. Because they were internal, they had security groups. So you could only accept traffic from some of your network, some of your instances. But it didn't just apply to internal load balancers. It also applies to public load balancers. You get security groups on all of them. You can tie it down by IP address, by range, by other security groups, whatever you want. Network ACLs, access control lists. We don't use these. Full disclaimer, I have not used them, but I could see how they would be helpful. For a small startup, we don't want to maintain these. Security groups for us are enough, but it was a nice to have. It gave the feeling that they thought a lot about security, that it was a fully secure solution, and we've gotten that from them since then. Elastic IP associations. How many people have ever associated an elastic IP with an instance in EC2? I hate it. You hate it probably. It's terrible. So you start an instance, you associate an elastic IP, then you stop the instance. IP is disassociated. Then you start the instance. It's still disassociated. You have to go do it again. And it's terrible. I hate it. It's very awful. You don't do that in VPC. In VPC, you associate an elastic IP address with a network interface that hangs around all the time. You don't stop a network interface. So they just hang around. In addition, as Eric had just mentioned, a number of weeks ago, they released ephemeral IPs, ephemeral public IP addresses. When you start an instance, you just say, give it an ephemeral IP address. This is a public IP address that will live with that instance for its life or until you stop or terminate it. Very nice. VPN support. Again, we did not take advantage of this particular thing, but in the VPC Amazon console, you can go in there, give it your hardware, and what your hardware is. It will give you the configuration back. You go put that in. You're connected on a highly available, scalable connection that you pay by the hour. It's very cheap. Last time I checked, I think it was 20 cents an hour. Pretty cheap. Back when I did this, in 2012, a year ago, reserved instances were specific to VPC or EC2. Now, that's still the case, but in my case, you could not transfer reserved instances from EC2 to VPC. It was not automatic. It wasn't allowed. Amazon worked with us very nicely, but it was nothing like what we had today. Our account managers were very helpful, but today you just go into the reserved instance console, transfer them, and you're done. Very easy to use. There are a number of drawbacks, things that we ran into that were subpar. Keep in mind, Eric knows about all of these, and in fact, I'll go into more detail about some of them. We've talked at length, and as usual, I anticipate him and his team will come up with solutions to these. So, I don't know, get after him or something. The NAT. For your private subnets, they are NATed, but not automatically. You must NAT them. I had done this before. I knew how, but even still, we have to run those servers. We had to set them up. If they go down, we have to manage them. We use T1 micros, so the cost isn't a big deal, but they're there nonetheless. It's a pain point. The setup time. Now, if you want just the default VPC, I understand, though I haven't seen myself, that the setup time is reduced. That was not the case for me. I took a number of days figuring out terminology, setting it up, trying to VPN, figuring out I was wrong, doing it again. I did it a number of times. I don't know if that's still the case for you. Anticipate a little bit of time just in case. There is a lot of new terminology, as I said. Private subnets, you need a VPN server. So if you don't have hardware, which was one of the benefits to using VPC, then you have to implement a software solution. That was us. That was our case. And it was a bit of a pain. I'll talk more at length about that one. Internal DNS. I had no idea for 6 months or so that VPC even supported internal DNS. I had no idea. Turns out there's an option deep somewhere. I don't even remember where it is, but it does support it. It's just turned off by default. So hopefully for you, the benefits of VPC outweigh the drawbacks. I think every customer should go to VPC. VPC is like EC2 2.0. There's nothing that EC2 can do that VPC can't, but there are things that VPC can do that EC2 can't. Things that you should know going into it, without reading them all. The NAT instances, there's nothing special about them. These are your own instances. You start them. They do that network address translation for you, but I mean, you configure it. You get it working. The subnets, again, nothing special about them. A VPC has multiple subnets. A subnet is defined by its relationship to a VPC, to an availability zone, and then the IP address range, the route tables, the network ACLs, and the DHCP options. There's nothing special. Just get in there, figure out the terminology. There's plenty of documentation to read about it. You shouldn't have an issue. So, migration. We got through the decision to go to VPC. There are a couple different ways you can go about this. Our account managers at Amazon helped us a lot. We presented, here's what we wanted to do, here's what we think is the best way to do it. And they said, hey, let's connect you to some people. They helped us out, helped us understand what it was going to take, that our solution was lacking in a few areas. Basically, there are two ways. You can go from EC2 to a public subnet, and then a public subnet to a private subnet. So two different migrations. The public and private subnets are both in VPC, so it's a half migration on the latter end. Or you can go from EC2 to private subnet, which is where you'll probably have most of your servers anyway, in one fell swoop. I was doing the migration. I wanted to do it quick. We're in a startup. So we went the route of EC2 to private subnet. And this posed its own challenges, but it actually worked quite well because we had spoken with our account managers, because we were aware of the issues. There are some constraints on migrating. In either case that you go, in EC2 to public to private or EC2 to private, you ought to know about these constraints. First and foremost is the communication between VPC and EC2. VPC has public and private. EC2 doesn't. It's all public. So VPC private subnets can speak to EC2, but EC2 cannot initiate connections to VPC private because it's NATed. It's not internet addressable. That constrains a few other things. All of your traffic between private subnets and EC2 during the migration are going to go through the NAT instances. This will become a bottleneck. You ought to plan on having issues there. I will go into more detail about this in just a little while. We had issues. We didn't plan for this. We weren't aware of it. Nobody said it would be an issue. We didn't even think about it. But the bottleneck exists. If your bandwidth exceeds that of your instance that is your NAT, you'll have issues. There are some things that just are not shared between VPC and EC2, and there are things that are shared between VPC and EC2. In fact, let me show both lists. Not shared are security groups. So you'll have to manage those by yourself. You could probably write a script to do it for you. Load balancers are not shared. Auto-scaling groups are not shared, and elastic IP addresses and associated limits are not shared. But by and large, most things are shared. Your instance limit, if you have a certain number of instances in EC2, you can launch the same number in VPC, no issue. No instance limit raising. EBS volumes, if you stop a server in EC2 and then start a server in the same availability zone in VPC, you can just attach its EBS volume straight up. Snapshots exist on S3 and as such are not associated with EC2 or VPC. So you can, inside of your VPC, create a new volume from an EBS snapshot that you had taken in EC2. The instance sizes, availability zones, and regions, all agnostic in this point of view. So we had a plan. Because EC2 instances could not talk to private subnets, and because we were going to private subnets, we wanted to move our web servers first. So if you go to www.lucid.com, you're going to go through an ELB right to our web servers. That's our top layer. We were going to take that and move it into VPC first, or rather duplicate it. We were going to leave existing stuff up and running. We were going to copy those servers, the scale group, the load balancer. We were going to copy it all in VPC and let that connect through the NAT to our database servers, to our services, to our caching, everything. We had tested the latency. It wasn't bad. So we'd copy it over there and let it talk through. Once we were familiar enough with it, once we were comfortable with that set of servers running, we'd change the DNS, drop the old stuff, and let it run. It would be running production at that point. We'd move each layer individually after that. Each layer would involve a certain number of security group changes. It would involve launching a new autoscale group, a new load balancer, and we'd just do those one at a time and let them be stable before we moved on. So each service would be released and be running for about 30 minutes before we did anything else. During this time, keep in mind private subnets are talking to EC2. That way, EC2 security groups had to be open to the to the IP address of our NAT instances. I don't think I mentioned before, but our NAT instances, I say instances because we had 4 of them. We had 1 per availability zone in US East, 1. And that way, if any availability zone went down, it would not affect the addressability, the connectivity in any other zone. We've seen those issues in the past, so we had learned. We launched 4 T1 micros to accommodate. Anyway, traffic from all of our private subnet through those 4 T1 micros out to EC2. There is a window of opportunity here for a hacker who had compromised our web servers to get into other systems. It was small and not a big deal, so we went with it anyway. And finally, after we'd moved top layer, services, cache, database, all the way down, we'd finally move our utility servers, our monitoring servers, all of our servers that all of our other servers talk to. And that would be the end of it. There is more detail here on my blog that I am not sharing. Here's a link to it. Feel free to go check it out and even contact me if I have left things out or been particularly vague. In graphical format now, just to be clear, because this helped us tremendously. Our account managers helped us see that we had to move layer by layer, starting from the front, moving to the back. Here was an oversimplification of our architecture. We had Route 53 pointing to the load balancer, which handled a number of web servers. It would talk in turn to services and cache, just like I had mentioned, and then a few databases at the bottom. First thing we were going to do is move it into VPC, move the web servers into VPC. Our traffic would stabilize. Everything would run nominally. And then we'd go with the next thing. For simplification and a lack of loving PowerPoint presentations, I've combined them a couple slides into one. So we moved system by system over there until everything was in VPC, nothing was in EC2, and then we were done. We had some pain points. I anticipate you will have pain points. Hopefully, this is all the pain points you will have. In fact, hopefully you will learn from my mistakes and not have even these ones. So in a countdown list, top 5. Number 5, the setup and terminology. Unless you are content with the default VPC provided you, will necessarily understand everything there is to know about subnets, about DHCP options, about your network ACLs. I apologize, don't look at that. That's not the next one, definitely not. You'll have to understand your routing, your internet gateways. You'll probably understand a little bit more about VPNs because you'll need to route appropriately for the VPN. Unfortunately, getting to know the terminology and setting it up, trying it out, seeing if it works, tearing it down, doing it again. I think I did mine 4 times. A couple times with the wizard and then once by myself, and that was the one that stuck, not because the wizards were bad, but because I had learned enough through the wizards that I could do it myself now in the way that we wanted it. You will have to do this. It is unavoidable. For me, it took about 2 days, 2-3 days. You're probably smarter than me. It should take you less. Number 4, dang it. Don't look at those. Number 4 is security groups. The groups, as I had said before, are not shared between EC2 and VPC. You could probably write a script that would transfer all of your existing groups from EC2 to VPC, but that wouldn't even be enough, right? Because during the migration, they have to be open in EC2 to your 4 NAT instances, and then you have to close them afterwards, and then open up the next layer underneath. It became tedious. You could avoid this, or it's not even avoid, but you could avoid the window of hacker availability to take you down by by having access to one of your systems by using the public subnets, by doing the 2 migrations, one to public and then one to private. At least then you could specify which IP addresses were available. That way it's more specific. They're not open to everything in your private subnet. I've talked with Eric about this one, and in fact urged him in particular to fix this, and perhaps he'll come up with some amazing solution that will communicate between the two with less hassle. It was a pain. You will have to manage your security groups regardless. There are different rules in place during the migration. Number 3, access to your private subnets. Because they're private subnets, you can't SSH to them. You can't do remote desktop. You can't get HTTP or HTTPS. You can't do your own diagnostics on them unless you do something special. For us, that was using VPN, OpenVPN to be specific. So those 4 T1 micros, not only were they our NAT servers, or are they our NAT servers, they are also our OpenVPN servers. That was nice because then each zone could fail individually and we wouldn't lose connectivity. In the event of an Amazon outage, you don't want to be worrying about your connectivity. You don't want to be scrambling to see what the problem is. You want to be scrambling to solve the problem. So I would highly suggest some high availability up in here. You can do that by SSH tunnels as well. The VPN solution that Amazon provides for your hardware is highly available. It has a failover, and it should work. I've not tested it myself, so I can't say it's worse or better than OpenVPN, but it is there, it exists. Number 2, and I'm going to spend more time on this one than perhaps any other because it burned us bad. Let me direct your attention to the funny meme I have up there. Try and turn one of those gears in your head. Doesn't work, right? That's very analogous to MongoDB's election algorithm. Sorry, Tengen, if you're in the audience. We use MongoDB for a number of different things. We use it for our document storage, these big, large documents. We store all of the changes in there. We have a lot of analytics in MongoDB. We use MongoDB quite extensively. Everything except for our relational data goes into MongoDB. When I thought of moving MongoDB, well, actually, how many people are familiar with MongoDB and its election algorithm inside of a replication set? Let me explain it. That was a minority. MongoDB requires, in a replication set, 3 servers. You have to have a majority of the servers elect a primary, a master for reading and writing. And they prefer strongly to read and write, but definitely write to the master, but strongly prefer to read from the master as well. You can disable it, but you need a master. You need something in the cluster that will say definitively what the data should be. And more often than not, for us at least, this algorithm doesn't work. We will lose one server, the master, and the entire cluster will fail. So when I thought about moving this to VPC, I got a feeling in my stomach. Let me explain it like this. I love flying. During this 30-minute flight, I was taking the controls, and I was doing all sorts of fun stuff, or at least I thought so. It was fun to me. My instructor may have been a little bit bored. Afterward, he took the controls, and he showed me what fun really was. So I'd played video games. I know what a stall is. When an airplane stalls, you know, it comes out of the sky. He showed me what a stall was, and video games don't do it justice. So when I envisioned a stall, the best thing that I could come up with from playing so many video games is that you're going along in your airplane, you know, flying along, and then for some reason either you're climbing too fast or you lose speed. A stall is when you don't achieve enough lift to keep the airplane in the sky. So I thought your nose just pointed down and, you know, you headed down. No. Here's what really happened. And keep in mind, I was expecting that. I'd played enough video games. So we're going along, we're cruising along, and I was watching the airspeed indicator. I figured something was up because we were approaching the speed at which we would stall. This indicator came on, you know, beep, and it continuously gets louder as you approach stall speed. And then we just fell. It was terrible, pit in my stomach. I was so scared that even though I wasn't supposed to, I grabbed onto the yoke and held on for dear life, and I was pushing it in because, you know, we were falling. The instructor was trying to get me to let go so he could fix it before we crashed. It was terrible. So he finally grabs my hands, pulls them off. He throws in the throttle, pulls it, pushes it down. I guess it was already down. He starts pulling it up at this point. And we come out of it just fine. But the speed of falling, you're aiming at the ground, and it's just a free fall. That was what I felt in my stomach when I thought of moving MongoDB to VPC. I wasn't thrilled about it, to say the least. I don't know what happened either. It recovered on its own. So we moved, because of the election algorithm, all instances have to be aware of all other instances. So we decided for this particular system that we would do the EC2 to public subnet and then public to private. So we got into the public subnet just fine, no issues. Uptime was great. And then we decided it was time to move into the private subnet. Keep in mind, public subnet to private subnet is, you can communicate that way just fine. We moved the first server, we brought it down. Everything failed over as it should have, and moved it into the private subnet. And everything, as soon as it came up, it became master for about 5 seconds, and then it died. The server didn't die, the instance didn't die, program didn't die, but all 3 instances failed to acknowledge or elect a master. So we couldn't read from or write to MongoDB. This meant all of our documents, it meant all of our analytics, all of our actions, everything was down. We had 15 minutes of downtime where people could neither open nor save their documents, where we lost all information about visitors to our website. It wasn't great. To its credit, after about 15 minutes of me furiously diagnosing it and coming up with nothing, it recovered. I don't know how. So when I had to move the other 2 nodes, it was like when my instructor said, "Want to do it again?" Nope, sure don't. We did, it worked just fine. It was just moving that one from public to private. I don't anticipate that you'll have the same exact error since I don't know what caused it. My best recommendation to avoid this, don't use MongoDB. Thank you. Number 1, the thing, and I put it number 1 above MongoDB because it was avoidable. With MongoDB, we didn't understand what was going on. With this, we didn't foresee it, but if we had, it was entirely avoidable. Because of this, I've talked to Eric about that. I'm sorry, about the instance. I've spoken with Eric about what the issue was. He's acknowledged it. It's my hope that he takes it into consideration and operates on it, gets something fixed quick, because it has the potential to still take down our system. Let me explain. During the migration, we had some instances in private subnet talking through our NAT instances, our 4 T1 micros, out to EC2. This wasn't an issue. For the web servers, when we brought them over, the amount of bandwidth didn't exceed the NAT. When we brought the cache, it was even less traffic because everything was talking to the cache inside of VPC instead of going to EC2. And as we moved our services one by one, there was less traffic and less traffic. However, once we moved our service that provides images, that allows us to scale our images and upload them to S3, things like that, just manages them and all of their attributes. As soon as we moved that from EC2 to VPC, we saturated the bandwidth on the micros. And it was very stupid of us. What this did was it introduced latency between everything that had to talk to any database, which is everything on our site, right? So our site went down, not entirely down. It wasn't as bad as MongoDB, but it was slow. It was unusable. You can avoid this, and we did avoid this during the remainder of the migration by just stopping those instances. We changed the routes to go to other T1 micros so that those would become more unusable for a small amount of time, and stopped the instance, changed it to a large, and brought it back up. Did that one by one, and as we did that, everything was fixed. It came back up as we expected it. It recovered fully. We finished the migration, no other issues. Then we took a quick check on our bandwidth through the NAT instances before we shut it off again. We were fine, so we took the M1.larges, turned them into T1 micros, and have been safely or happy ever since. The T1 micros seem to do us just fine. I would highly recommend you anticipate the amount of traffic your NATs will need before you move into VPC. That's it. So I hope you enjoyed the topic. I wish you well, rather, in your VPC migration if it's forthcoming. Good luck getting off of MongoDB. Give me a shout out. Let me know how this was, if I can help you in any way. One shameless plug for Lucid Chart. We are currently hiring. We're on Amazon. We're very excited about it. If you're excited about it too, or using any of the technologies that I had listed previously, contact me. Go to lucidchart.com/jobs. Do whatever you want. But I invite you to do that. Thank you for your time, and if there are any questions, I'd like to field those now as we're a little bit early.